Hi, I'm Dr. Chris Crawford, Assistant Professor of Computer Science at the University of Alabama. I'm currently working on research projects at the intersection of physiological computing, human-computer interaction, and robotics. One of the projects I'm very excited about involves physiological computing education. The area of physiological computing explores ways to design systems capable of measuring our physiological activity. This physiological activity oftentimes includes brain activity, muscle activity, and heart activity. One practical example of technology that utilizes this type of approach involves neuroprosthetics, which are commonly used to assist those who have lost functionality of their limbs. Now, while this is a very promising area and has a very promising future, there's limited work looking at how do we train K through 12 students to actually be successful in this area. Over the past couple of years, I've explored various ways to get K through 12 students and educators involved in physiological computing. By far, the most successful approach has been through a program that I created called NeuroBlock. NeuroBlock is a visual programming environment that allows students to build brain-computer interfaces. And so in this program, they basically use puzzle-style blocks to create games based on this brain activity. And this program is built on top of design insights from a popular project called Scratch that some of you may be aware of. In particular, students were able to build these digital games that captured their brain activity, and they were able to use our interface to add logic and to also map specific brain states to specific actions in this digital environment. The motivation for this work came from a public event that I helped create called the Brain Drone Race. And the Brain Drone Race involved a public event where we invited the public out, and the public basically observed two people using these physiological computing interfaces to competitively race drones. And so this event got a lot of media attention. It's been viewed by millions. But we had a lot of K through 12 students come and say, hey, I wanted to build something like this. How can you teach me? And so that was the motivation for NeuroBlock. Now, this current project that we're working on, it only involves digital feedback so that students can build things in a virtual environment. But we would love to move this and extend this towards supporting a physical component. And in order to do that, it's going to cost about $400,000 over the next 3 years when you look at the equipment, personnel, and students necessary to build this project. The team includes an interdisciplinary team with personnel and researchers from education, computer science, and nursing. And so if you're interested in learning more about this research and other projects, please visit htil.cs.ua.edu. Thank you.